Goal for the rest of today is to get the 2 new sample environments commented, cleaned up, documented, and also to put a tutorial on our homepage for that. Do that, and then we're probably going to see if we can get some sweeps going on some of the more complicated M's, try to stress test some things, try to fix some user issues, like some user submitted bugs, just a variety of different things. So speaking of which, Captain had some issues. Let's see if he's around and help with your set. Cool. We'll see if he's here, and in the meantime, we will that over there. And keep on this little refactor. Okay, that gets rid of this function and this function. And that's 228 lines, including comments. Let's see if there's anything in here that seems redundant. Okay. Got our structs. Client has a struct. Yeah, I think that's fine. Have the extra client struct like that. I am a little bit knowledge impaired, real RL learner. Could you explain, if not taking too much time, what is the exact issue that PufferLib is targeting? My understanding the direct goal is to sit between the environments and learning how to deal with vectorization. Therefore, am I misinformed? So that is what we started off doing in Puffer. So like in the first few months of dev, that was the original goal, was that multiprocessing, as it is typically used, is very janky. It only supports certain types of M's. Doesn't have native multi-agent support. Doesn't support complex observation and action spaces. Whole bunch of problems, and it's incredibly slow. So the first thing that PufferLib did was fix that. So we have very fast parallel processing. It works with our own environments. It works with gymnasium environments. It works with petting zoo environments. It uses much more optimized shared memory and a whole bunch of other tricks. Asynchronous simulation, double buffering, lots of different tricks that are in the paper to make vectorization up to like 10x faster. So that was the first thing we did. But that's like we have 2 major releases basically since then. So now we also have 20 ultra high performance environments written in C that we use for all our own research that run at millions of steps per second. And we have a trainer that actually can train at millions of steps per second. So, I mean, if you compare to like the libraries that we were trying to build infrastructure to support before, like SP3 and RLlib and all those, we just train 100 to 1,000 times faster now. So we still provide these compatibility tools for use with other libraries, but really at this point you should consider using our tools because everything is just so dramatically faster. We're also doing our own algorithm research now, so we have a better PPO, like PPO with additional things that is just better across the board. We have benchmarks on all of our environments. We're setting like SOTA on other people's environments. So it's become much more than what we started essentially. It's a comprehensive effort now to just make reinforcement learning ultra fast, ultra simple, and very stable and sane. That's what Puffer does. And I stream all of the dev because why not? And it's all open source. And we're always looking to get more people interested in contributing, building environments, helping us run experiments, helping on science side, all the different things that we do. Trainers departed from TorchX. No, they're still implemented in, our trainer's still in Torch. But the thing is, it's just like, it's so much more efficient than what was being done before. Like, there were a half dozen different places where people were just losing 99% of their perf in training. To give you an idea, right, like the vast majority of training that's done in reinforcement learning, like you look at your average lab, a lot of them are still on single-digit 1,000 step per second trainers. Some of the better ones are now in like double digits, and then the ones with full GPU M's sometimes get triple digit, like 1,000, so like 100,000 or something. But that's like a very few labs with a very few environments that can even do that. So our training, we run typically between 400,000 and 4 million steps per second, depending on the architecture and the model size. A lot of our simpler test M's that we use for primary research run like 2 to 4 million steps per second training on one GPU. And our training code is simpler than the slower libraries that it replaces. It works out of the box with multi-agent. It works out of the box with a whole bunch of things that aren't even supported generally elsewhere. The environment code is way simpler. It's way easier to build environments in PufferLib than it is in JAX. For instance, for like PyTorch accelerated GPUMs, way faster to build our stuff because you just write arbitrary code and it's fast. Yeah, it's like a really comprehensive effort, but we're not giving you our own trainer API that's like you have to go learn. It's just PyTorch. It's very vanilla PyTorch. It's just that our code is way better optimized, right? We didn't come up with like a crazy new interface. It's almost identical to the Gymnasium vector interface, just faster. And so we really try to make stuff just simple. Working through S&B now. Haven't finished P1 yet. Notice the proper vectorization matters a lot in responsiveness. Yes, it does. Multi-agent sounds like a nightmare to marshal. It's not, is the thing. It's literally the way that we do it. Multi-agent is no more complicated than single agent at all. So this env that I built here, actually, can I eval this for you? Let me see if I can just remember which of these checkpoints is any good. Okay, so here's a multi-agent environment about PufferLibs eating stars. I built this just as a tutorial env, as like a really simple thing to get people started. This thing trains 100 million steps in 25 seconds on my local GPU. It worked instantly with our default training setup. And I built this thing yesterday on stream. So there was no code for this yesterday, and now it just works. Welcome, sup. What's up? So yeah, this thing trains 4 million steps a second. And like, it's a very simple env, but this is really, really clean as far as like multi-agent just like foraging type behavior goes. Yeah, the evals are on the website as well. So you can literally watch agents playing the games in your browser. And they're running locally as well. I will be honest with you also, I've never read this Sutton and Bardo book. I do a lot more engineering side stuff. So that really seems to matter a lot. I do some algorithm stuff, to be fair. We have like some algorithm advancements in Puffer that make a big difference, but so much in RL is just getting the engineering right. The way I look at it is that there have been a lot of mathematically very smart people in RL. That's not why the field is stuck right now. That's not why like everything is so difficult. It's because all the code is slow. Aren't some parts of environments inherently serial, such as environments that get more complicated, they will be less easily vectorized? Well, here's the thing. So we just write stuff in C, but we don't care if things are serial or not. It's not running on GPU. Our code runs like 1 million steps a second. So we're not just like running one environment per core. We're running like 1,000 environments per core. So if some of those are slower than others, it doesn't matter because it gets amortized out anyways. And like we literally end up saturating the GPU with 1 or 2 CPU cores with most of our environments. So like when you get to a certain speed threshold, it really doesn't matter. More headless environments? Well, that's one of the things we do, right? Like it's one of the main ways that we scale out the open source contributor side, because the easiest way to get new people into RL is say, hey, you know, if you want to learn RL, come up with a new environment that you would think would be interesting, build it, and go through the process of building the environment and getting RL working on it so that you see the full end-to-end loop. So that's how we get a lot of these environments contributed. It's from people that are trying to learn RL and are like building cool environments. I build a few of them for myself for various research purposes as well. Those are also there, and the library grows that way. We have our work that we do on infrastructure and good training. We have our own algorithms. In this next update, we're shipping our own really high quality hyperparameter tuning algorithm. We're shipping our new trainer, which has a new advantage function. It's got a whole bunch of additional improvements. It's very fast. It's got very nice logging integration. So we really do everything in RL. Like this is a comprehensive effort to like fix all the things that are wrong with this field. Fork the repo and working on Flappy Bird. Awesome. We would like a Flappy Bird env. Maybe a Flappy Puffer env. Maybe load the Puffer in. I have no idea how nobody has submitted one of those yet, but yeah, go for it. What do you do for logging? I noticed logging is very underdeveloped in RL space. So we just have a very nice way where anything that you have in this log struct, anything that you put in this log struct, there is a very clean way to just get it integrated with, aggregated across like 1,000 environments at reasonable intervals. And then we just have backend integrations with WANB and Neptune. And it's like 20 lines of code if you want to add your own of those. So like when I do my experiments, I'm not just looking at like one plot, right? If I go to Neptune here, so I have 30,000 experiments from the last few months. And I can go to any of these tags. And like I can go to this maze tag here. This is a hyperparameter sweep. And I can see all these graphs that are getting logged from C. Hang on. So I have all these graphs from C, but then I also have these dashboards, which I can actually see like hyperparameter sensitivity I can see like this is the stable regime for learning rate. This is a stable regime for gamma. It's very high. I can see like lambda. I have all sorts of different views. I can see sweep progress, so I can see like how the parameters were fit over the course of a sweep and sensitivity therein. I just have a ton of insights here, and it just comes from the speed, frankly, because like these aren't necessarily things that people couldn't do before. The difference is that these 100 experiments, or these like 178 experiments, this is like, I don't know, 30 billion steps of training data or something, and this ran overnight on one GPU. So like we just have so much more data and so much faster at such smaller scale that we can just do things that would previously have been reserved for Google, which is why we've been able to make so much progress so quickly. Why do you prefer C? Why you preferred using C inside? I assume that means instead of C++. It's just simpler and easier. Like, I don't want to deal with the giant C standard library. I don't want to deal with people with Boost. I don't want to deal with like all the crazy things with that things do in C++. C is just really easy. That's all. I like simple things. It's just so easy. Like any of the environments that I've worked on, I can just give people the code file for it. Like I can give a first-year undergrad the code for Neural MMO 3, which is arguably one of the most sophisticated RL environments out there. And like a first-year undergrad who's taken their first systems course can just read that code from top to bottom and will understand everything. Because it's just that easy. Like why do hard thing when simple things suffice? And runs at 1.5 million steps per second on one CPU core. But what I'm currently working on here is this is the multi-agent tutorial env. I just built this yesterday to be like, you know, the sample project where you can like get a sense of how a couple different like basic envs are written. So this is like, you know, I tried to like really just pare it down to a very basic env, and it's like going to be way more commented than the other env files are. I'm mostly interested in inter-run logging. I was more talking per run logging in Viz. How learned behaviors interact, similar to how ice plots work for forests. Yeah, I mean, we kind of just have standard metrics for that, right? It's just like you log whatever you want from the env, and then the key for a lot of our interpretability stuff is just trying to make as many of the envs as possible human playable, and having like a really quick feedback cycle on evals, right? Like, let me just show you how. Let me show you how we train an env in Puffer, right? So Puffer train. Hopefully, I haven't broken it. Okay, Puffer train and Puffer target. This literally just runs our main training script. So this is the same as doing like Puffer Python-m PufferLib dot like PufferL train. It's like the same thing, just a convenience. Okay, so now here we have this thing training at 3.539 million steps per second. Okay, and you get all of this data in real time like this, but also if you just pass Neptune or Wannabe, it'll also log all this stuff online with full graphs. Okay. And now after 20 to 30 seconds, this thing will have trained 100 million steps, which is typically like an overnight run for most of RL researchers. And then experiments, just see what it named it. And then we just do eval, which runs the exact same script, just not you doing the training part, and it returns rendering arm. Load model path 8. So, and this is the model that we just trained. And we have like experiments that take on the order of seconds to minutes for like a pretty surprising range of environment complexities. Like things that you would normally expect to take multiple days to train, we just do it in like 5 minutes. So you kind of just have a lot more interpretability in the sense that you just get faster feedback loops. That's all. You can just go watch your agent play the game a bunch. And I don't have it set up in this end, but for most of them, you can actually like hold shift and you can take over for the AI. So you can like try to like shift around the way it plays. Yeah, there's a bunch of stuff you can do. Python-based and Majoko definitely can't keep up. Yeah, I mean, it's not even close, right? To be fair, even if you give us a Python env, we normally still make it like between, I'd say around like 50 times faster than you'd normally get in like SP3. Like we've been handed unoptimized Python envs and we still get them to run like 200,000 steps per second training. But like in our C version, it runs 2 million steps per second, right? But the thing that's like the emphasis here is just how easy this is. Like, this isn't hard. That env is 200 lines of C. That's it, including the renderer. With a very thin binding layer. Do I need to run overwork equals true to run 96 Python envs? Recommend keeping both workers and batch size sets to auto. And those are the same as what they were in 2.0. So, Linky, the way that I would suggest including the render, well, the renderer is super, look at this. It's just Raylib. This is the whole renderer. Raylib's awesome. Also, if you want to do Python, Raylib has an identical API for Python. You can basically write the exact same code in C and Python. Yeah, Linky, so I wouldn't suggest doing overwork. Like, that parameter is off by default because you shouldn't do that. Generally, what you do is you take your cores, all right, you get like, and then you run a number of environments that's going to be divisible by your number of cores, not threads. So, like, if you have 16 cores, then you do 96 envs on 16 cores. So what is that? Is that like 6 each, I believe? It'll just end up running 6 envs per core. And the way that the auto things work is, well, you might have to set some of those params manually. I can help you with that today, though. Like, if you're stuck on this, I can like look at your config and I can just fix it for you. That's just the easiest thing. I'll start learning Raylib right now. Yeah, it's really nice. Rendering is one of those things where it's just like, you have like Pygame and just these awful libraries. This is so much better, and it just works effortlessly in C. This is all of it. It's just got like really basic stuff like texture loading and like low-level things that you would want, and then you just write loops. Easy. So yeah, I mean, this environment here is already committed. I will be pushing these comments up today, and then this is going to be part of a tutorial on the website for the new version of PufferLib. So it's going to be really easy for people to write and contribute environments to PufferLib, learn some RL in the process, and then, from there, once you get comfortable with all the things, if you don't have a huge amount of RL background, right, like this helps you get comfortable, and then you can actually start helping on our research side, right? Like, there's so many different research problems that we're interested in. First of all, just like new types of environments that pose interesting problems for reinforcement learning is a great way to contribute. We have algorithm side for people that are more mathematically inclined. We've got all this RL infrastructure and optimization for people who have like the more engineering side of things, right? There's like tons and tons of stuff to do. It's a comprehensive effort to make reinforcement learning fast and sane. Gives me warning saying numm should be, yeah, link that, Linky. Like, just paste that in Discord and let me know, because I'll look at that. It's possible I have the warnings misleading. And Captain's going to be here to have his stuff fixed in a second as well. We don't need this. We do not need this. Make this env. Do init. Allocate. There. You don't have to join the Discord. It's there if you want it. Looking to go towards meta RL. If I ever think of some kinds of M's which would make sense, I'll try to contribute. I'm fully formalized myself yet, so it'll be another year. Bit opinionated. Current neural architecture search is quite naive. It definitely is. So the tricky thing that I think is like the thing that's I think difficult with the neural architecture search is like if you want to make this thing really work, right? You want to make it fast. And the tough thing is neural architecture search tends to generate like really slow models. Because like you'd almost have to generate and then like run optimization on all the kernels or something weird. Like fuse kernels or something. There'd be like a lot of low level stuff, I think, to make it really good. I think you'd also be surprised at how quickly you can learn some of these things. We've had people come in with no reinforcement learning background whatsoever, just like a software eng background, who haven't even done a ton of low-level dev, and they've been like very, very capable at like helping and doing all sorts of interesting things around Puffer within just a few months. We really, really try to make it as low friction as possible, and like you can just learn things quicker when you have lower turnaround time for like checking things that you want to check, right? Running ideas, experiments, and things. It's way lower turnaround time for everything. That's the idea. Definitely naive for a good reason. Defining a search space is hard. It's hard, and it's also like I don't know what flavor of neural architecture search you're interested in, right? Like if you're looking at like old like neat or hyper neat or like any of the like CPPNs or stuff, right? Like the really small evolved networks that do really interesting things just basically via function composition. They're really cool, but I haven't seen them scale very well, and they're also like if you do scale them, it's very difficult to make them fast. Which is pretty tough. Generally, I think I like the space of Evo in general. The thing is, like, you want to make everything like nicely shaped networks that run fast and like run on big batches. Yeah, Captain, I'll hop on Discord. We'll do that right now. I've been waiting for you. It's not letting me click the channel. Hang on. Oh, there it is. Hey. In ENAS and darts, yeah. Neat. Paper, neat. This is like all stuff like Ken Stanley adjacent stuff. Yeah, we're always happy to have contributors. It's pretty much if you're pushing, if you're contributing code to Puffer, you'll see that you get lots of feedback on stuff. All right, Captain, you got bugs to fix? Or I have bugs? Let's see. On here. Yeah. Boom. All right, what do we got? No idea. You might. I don't know. Man, this Python packaging's cursed, okay? I'm working on the best I can. We're going to have the demo M's done today. That is the goal. And then I will go from there. Let's see. Okay, so I have there's Ninja there. Yeah, it's built. Okay. Using your correct. I see it's using the Python in your PyM, so it's good. Ah. Okay. So I see what happened there. Uh, can you run NVCC? You don't have NVCC. Boom. So basically what happened there, it's a good report because that should be, I should have that working so that it's an automatic fallback to that. But what basically happened is it compiled the CPU version of that kernel for you because you don't have CUDA dev tools. So that is still a good error report because it should not fail in that manner. It should just be slower, basically. It should just build the CPU backend and just use it for you. It's probably, well, it goes in your container. It needs to be installed in the container, and it's like CUDA dev tools. Something. It doesn't need to be, it's not on the host that you need it, though. Are you not in, oh, you're not in a container. Yeah, then you just need CUDA dev tools, yeah. Well, we use the base container, right? We use the NVIDIA base. But it's just like CUDA dev tools or whatever if you look it up. So the goal is that this should not prevent you from running PufferLib. It'll just prevent you from having the GPU kernel. So I will go add that fallback after I fix all the other stuff today. Because it correctly compiled the CPU version. It just didn't detect that there was no CUDA version for it. So yeah, that's all. You don't have NVCC. You should have the like you should have a CUDA compiler if it's correctly set up. We do not have a 1-800-PUF number. We should get one of those. Can we get 1-800-PUF? Alright, you take a second to figure that. I'm gonna go take a quick call. Get back. You figured out, Captain? Let's see. So I added a warning for that in the latest version. Is it synced? So there should be, there is an explicit check against total mini batches being 0. Like yesterday. If you're on a fork, you would have had to have pulled from upstream or synced it. I will be right back. Hey, Quixotic. You were live earlier. What happened? We went for breakfast. I just do a quick stream in the morning because I have breakfast at 10. So it's some days I run, some days I don't. So it's like I'm on for half hour to 2 hours depending on the day, and then I'm back for the rest of the day. Captain, how's it going? Okay. Is this old Scython or? So run it with serial backend. If you see a seg fault. Yes. Yes. It also works from CLI. Like vec.backend serial will do it as well. Capital S serial, that's this time though. Well, I'd have to like post-process the string otherwise. It's because it uses like it just like it looks for the vectorization thing that matches that string. Basically, it's a string match on the classes in vec. Yeah. Okay, so that is because you have env num set to 1. You shouldn't do that. So what's happening there is that you still have your mini batch size set to 8192. All right, and the batch size is BPT horizon times the number of envs. There you go, that's why. So the good thing is we've actually made it so you can debug that now. If you just head setup.py. No. If you, okay, yeah, you can do it that way too. Yeah, but there's another command in there you'll need. So debug equals 1. You can compile that. Yeah, that's fine. But then to actually run the thing, you're gonna have to get the command from the setup.py. It's just a comment at the top for now. Okay, so CUDA visible device, yeah, all that stuff. And then you can just set that to run your env. I would do it with serial backend and run train. You get a trace out of any of these? So when I do this, I normally get with that command, I normally get a stack trace that goes into the C. Well, I don't have anything set. So it's however it's set up.py, like setup tools. Yeah, I don't know. I just have the dev container is just set up with Clang. I don't know either. There could be a stack trace at the top of all that spam, for all I know. All right. So the thing just pops up as like an operation not permitted. That's like some weird permissioning bullshit with my OS. Has nothing to do with it. And that happens with debugger specifically. What doesn't? Well, then that means whatever compiler I have is working. The Python ecosystem is not known for being particularly smart. Yeah, I'm seeing this. I'm seeing this linky. Why that doesn't exit cleanly? Multi-discrete outputs. Should we do multi-discrete outputs? Yeah. Action dim is off. See, that bot. You argument. Thirteen 3.0, which is default Ubuntu 24. I'm pretty sure. Unless we find that everything's screwed at the last minute, like. Yeah, I mean, it just makes more sense to go in the major versions. There's like version inflation because of all the AI companies just like skipping normal versioning, so it's like fine, screw it. Hmm? Oh yeah. Well, then every update's just going to be a major version. Like, oh no, it's a breaking. It's like, shut up. You fix RL. The thing is, nobody actually follows the versioning, and everybody just has it stuck into their config files without like a pin to a major version anyways. So like it just will automatically upgrade to breaking versions. Like the whole system is wrong for that. Yes. Hmm. Cool. The thing is, Python's really not built for it though, because like the correct way to do this, right, would be that you would have isolated, like, let's say you have two different dependencies that both have NumPy. They would both build their own versions of NumPy, like statically or whatever, however they want to do it, and then you wouldn't get conflicts. But because everything is global, like, you can't pin versions, otherwise your pin NumPy breaks the minimum pin version of the other library, because we don't know what static linking is apparently. Um, and like everyone has to share the same bloody version of everything. But it's just a mess. Like literally, this should not be a problem, right? Literally, versioning would not be a problem if it's just like, okay, your library basically takes all the code. It's like vendored versions. Everything is linked reasonably so that you're not sharing the namespace of your deps with other things that need different versions of that deps, and you're done. I mean, Go generally seems like fine. I mean, we can literally do all of this and see. Now, you don't blame C for this. This is Python being dumb as hell. All right. Okay, but like, if you just run the sanitizer from the C build, it works. So, right? We use Clang as well. I don't know, man. I'm working as fast as I can on it. I kind of don't want to think about it. I just want to, like, get it done. It's like, it's just, it sucks. I hate releases. It's really close, but it's like, if I think about, like, even if I think, like, oh, they're, like, 20 more hours of, like, real work to do, it's like, I can't do those 20 hours. It's like, I'm just so bored. I want to get back to doing real things. You know? I haven't written one of these, like, networks in a while, and they're kind of annoying. Yeah, this is the rare watch neural nets in pure C content. Have to make the network a slightly different way, I think. Okay, so we're gonna try this training. Split sizes. I figured it would be good to at least have the tutorial on like how we do our how we do like custom nets and stuff. What's wrong with you? Okay. Our model. So I guess then it will just be, can make this a fair bit simpler. Totally make this simpler. Yeah, this will. Forward linear. Still not working for you? CMake makes it work suddenly. Make, man. That's such a pain in the ass because like I hate when it's like one stupid heavy tool makes you use another stupid heavy tool. Because it's like ugh, this is how you get this is how C turns into React, alright? We used to write real code, let me tell you. I mean, that's people doing weird shit. It's pretty damn easy when you just write loops and conditionals and watch your code be 1000x faster and shorter than everything written in the modern era. Like, I like C. It's easy, It's just easy. What's it say? Because that's weird. The debug commands were supposed to fix that. Like it's supposed to fix this ASAN linking or whatever. This is the action space. Nine and 5. This runs out of weights. To Yeah, it's obnoxious. I mean, this is why we have it, so that it should be easy. I mean, to be fair, this is also kind of like why we ship the dev container. So it's like there are a million freaking stupid setup things that can be different. Here's a damn entire computer that's the same as mine. Let's use. You have access to a box, don't you? Just do it there. Box is for you to like fiddle with. Probably not. If you get stuff the way you need it, I can run a thing, but I don't know. Does that actually? It depends what box you have. I will also just have the new containers done pretty soon here. Just finish these darn tutorials. What? Weights input. Weight state. $137K parameters. That seems correct. Something's just slightly off, I guess. Okay. Now, get a overflow of some type. And num agents times nums. Fine. Oh, wait, num goals. This is it. Okay, we got it. Work. Still no. Breast sanitizer. This is what you have to do. Wrong order. Here we are. These puffers don't seem as smart as the other puffers. Why don't I get symbols? I don't get like symbols here. That's crazy. Actually, version made a difference. Oh, that sucks. Let me retrain. I think I am loading this correctly. I think I just trained a bad model. Train this slow. Right? Shit, I broke something in the end in the process of refactoring, I think. Oh. Yeah, I kind of forgot about that. That's weird, because I can definitely run with device CPU. So, like, huh. Don't set that. Maybe don't set that. That should fix that either way. What was the other one? That's bizarre. There's so many of these little, like, stupid things, man. Oh, yeah. I have a feeling I'm gonna have to go through line by line like the old version and see what I messed up. I mean, you get that for a ton of things. Like, I just fixed one of those not initializing PufferLib before calling load texture. Yep. Got the puffers vibing again. It's like, it's cool, right? I think we should do way more with stuff like this in the future, but I gotta get this update out first. And I probably have to go recover from all this stuff I've been doing, get my head just on straight, and go, like, I don't know, lift some rocks outside and watch the birds or whatever. You think I'm joking? I've got stones 70 to, I don't know how much the big one is. It's between 150 and 200. I've got, like, I've got an overhead pressing stone. I've got like a loading stone. It's fun, you know. I got all the barbells behind me. Speaking of which, thanks for reminding me. I got to do my first set of squats because I've been. I got a screwy knee, so I got to be careful. So this is just gonna be at the cardinal. Gonna see if that's the cardinal I've been looking for. No, it's not. Okay. Yeah. What do I put on? I think we'll try. We'll try like 250. Right back. Yeah, knees didn't like it. Everything else is fine. This is the funniest thing. So I put up a birdhouse, and I've got two bluebirds in the birdhouse. But every so often, some other bird comes over to like, Oh, that looks like a nice box you've got there. And then there are two very angry bluebirds chase off whatever it is. uh, this is my spot. And I have it like maybe 30 feet outside the window, 25 feet, 30 feet outside the window. So it's very amusing. Ah. I've got two 26-inch monitors. That's it. One's vert on the left, and then my main monitor's in the center. But then I do have to look around this big frickin' camera. The camera's on a tripod where I have my desk like 2 feet off the wall, and the camera tripod has two legs on the desk and one leg like extended all the way down to the ground. And then the camera's actually mounted upside down, like on the front side. It's a whole thing. Uh-huh. What random number? What's the data type? Then that sounds like it's getting overwritten, not by, like, that's like some random memory overwrite. Is it before or after? Like, I mean, OBS has to be the right size. There's no check on that, right? Like, all these things have to be the right size. No, because it's all your memory. Like, that's you're overwriting within your own struct. So that's actually one of the things where people say, oh, you should use like area allocators. That's why that's dumb. It's not the same. In PyTorch as in C. Like, the model does better in PyTorch than it does in the C export. Mm-hmm. Would have to be. Pain in the ass, though. I've definitely seen this type of thing happen before where, like, behavior degrades somehow. I mean, but it's like, the thing is, it does... Like, these guys do go for stars. They're just not as good. They? Ah, I see. Well, the log field is just for things that are supposed to be logged, and they should all be floats. Mm-hmm. Well, yeah, no, I think so. That doesn't seem like a good way to scale it, anyways. Like, if you have a scripted bot that you want stats for separately versus a trained bot, that's one thing. But if they're like all trained bots, then you should just log them all. Like, you shouldn't have different stats per drone, I wouldn't think. Yeah, you can have that, technically. But then if you really want to check that for now, just like put 4 agents worth of logs and call it a day. Put 4 agents worth of log spots and call it a day for now. Yeah. Well, then just have 2 till we get your good policy. There's something screwed up in the net itself, I believe. I mean, I can always fix this as part of fixing the demo. This Malik leak. Lib ASAN. Yeah, it says installed. Hmm. Think there's anything else that you allocate? Do we use Clang? We do, right? Yeah, Clang. Oh. Why is platform not defined? Oh no, it is. Never mind. Platform. Trying to fix the debugging experience for this. Not that. Oh, it's GPU driver stuff? Okay. Alright, whatever. I think this is enough for now. Just add a couple comments. Careful or I'm gonna find a way to delete setup tools and not include CMake, and the whole entire project setup is gonna be a random shell script. I don't know, I tend to build okay stuff. Hey Aaron, what's up? We're on stream. How's it going? Okay, awesome. I am fixing our demos. So we will have very nice M docs. And then I might even send these to you to see how bad these look for you. I don't know. Maybe we'll turn you into a C engineer just yet. I mean, it's not that far off from this thing that I just built. So why don't I just give you this? It's like I'll finish. You can beta test our doc. So I mean, if you can figure this out, having done probably mostly pure Python for the last decade, um, then it should be pretty easy. Your builds. Yeah, so this is pretty much ready to go. Here, check this out. The one thing is I have to fix our library, like our neural net library, because there's a gap with Torch, because the networks don't look quite as good in like it's loading the network, but I think there's like some drift or something. The puffers still get the stars, just not quite as well as in Python. So this doesn't look that bad. So this is running in pure C right now. These ones are not as snappy as they were. So they'll be way snappier when I fix the Torch library, but yeah, so that's just like drift with our network. But if I just do, for instance, if I do this, that was running pure C. Now this is running with PyTorch. See the puffers. Yeah, so there's just like some numerical stuff going on with our pure C library. But it's pretty cool because let's say I fix this. Okay, so this is a 60-line C demo file. And then the source code for this environment, this whole end with all of the comments included, and it's like nicely commented up, is 230 lines. And that's literally it. Now, the one thing we use RayLib as our renderer, and then for that neural net demo specifically, if you want to do that, we have extensions puffernet.h. And I've been thinking of replacing this thing with like the tiny grad C backend, but it's also just kind of cool that we have this thing. It's like a single file, like no dependencies, C neural net inference library that's really easy. So that is the target env done. I'm going to comment up the squared env. I'm going to put them online, and then I can give you docs for that, and you can see how that goes. Because the chase env thing, you can train that at probably 4 million steps a second. Yeah, just insta-solve. From the reinforcement learning conference to actually have reinforcement learning. Okay, there will be plenty of it to go around with a puffer. Let me see the thing that you put in chat. Like LP. So are these two different graphs? And then is this Is this perf? This is an eval perf though. This is the training curve. Hmm? Okay, so according to the eval, which isn't really quite long enough, but according to that eval, it looks like they dip about the same amount yeah, they dip about the same amount. Okay. Yeah, so I mean just put all this stuff together and send over the final stuff. I mean, you've basically done everything that we could have asked for on this, right? Yeah, it's like it turns out that the baseline got ridiculously good in the meanwhile, which is kind of what we were trying to do. But like it's pretty much like this helps whenever it is possible. All right, cool. Good LP stuff for Puffer. And hopefully, I think that there should be a way to get some version of this into like more Puffer experiments as well. Maybe you'll be interested in doing that side of stuff when you have more like M's that are easier to work with and interpret and randomize over and all that. Oh yeah, you can of course finish everything. Let me just. I can commit this anyways. I can show you this code. Oh, that's actually way easier. So, I mean, this is the code. Like, this is the type of code that you write for Puffer M's, right? So I have commented here, like, which of these fields are required, and most of them aren't. So it's like, this is a required log structure. You have a couple structs, which are literally just data classes, right? Here's your env. And then this is the thing setting new goals for itself. It's literally just, I mean, if you just like replace the parentheses with like white spacing and stuff, and like, other than the fact that there are pointers for things that in Python, like everything that is not a primitive is just passed by reference anyways. Like this is basically Python. Like, because you can write this in any language. It really can be. And like, this is the observation function right here. This is it. It's not bad either. All right, and then here's how you reset the env. You just randomize the positions. All right. Basic stuff like clipping is not built into C, so you write your own clipping function, but whatever. And then here's the step. Here are the dynamics. Yep. A little bit of memory management, right? Little tiny bit of memory management right here. But and then this is the whole renderer. This is probably the coolest bit. You can't even make the renderer this good in Python. That's the whole renderer. And this draws the puffers, it draws the stars. It would be even shorter except for the fact that I'm downscaling the textures as well. Or no, it's not that I'm downscaling. I have it's a like texture sheet, so it's like a texture atlas. And that's everything. That is, and then the only thing you need to do, it's a little bit annoying. This is the binding file. This is what you write to bind your env to Python. So until you start doing crazy things that require you to really get into like the Python C API and stuff, like, I mean, this is pretty simple for just binding your env, right? It will get you writing C yet. I gotta tell you, it's so much cooler now just to be able to like try out whatever the heck I want and not have like some big engineering stack I'm dependent on. But the thing is it's super thin, right? So basically like I've got a 500 line script that replaces the need for like having some Python thing, and it just uses the Python. It's just like a small wrapper over the Python C API. Like it hardly even does anything. It's really nice that it's C, not C++. I mean, if we need to, we can. I mean, but the thing is, it's legitimately, it's like, it's not that hard. And like, like these ends, you can pretty much, the way that these ends are written, you can almost just copy paste them into CUDA. And like, you could just run this env on the GPU. CUDA's just C. Just C that runs on the GPU. You have to set up like the parallelism flag, but it's basically, you just parallelize across like you just do one thread per env copy and you're done. Well, I mean, you can paste this into CUDA, right? Like, apparently nobody else can figure out how to get basic C to run on a GPU reasonably. But look, like this is, where's it? Yeah, this is our extension, our CUDA. This is our whole CUDA extension file. This is the puffer advantage function right here. That's it. We had to. This gets called on. This gets called on everything, every mini batch. It's actually really obnoxious that we have to ship kernels because it makes the whole build stuff like way more obnoxious. That's the one thing that really sucks is dealing with setup tools and like Python compilation garbage. Like that sucks. But like the actual language itself, like it's all easy. Hmm? Oh, cool. Yeah, I should chat with him. Yes, and where were you chatting with him? And send us a message because I was working on that as well. Okay. Yeah, if it makes sense, send over. I'd be happy to chat with him because I mean, I'd be very happy if somebody just helps with that and does that. That's like doesn't have to go back to the drawing board if he already has stuff like at least like at least use our ends to eval the thing so it actually you make sure it actually works and it's not like yet another Atari overfit. I mean, at this point, I just want all the algorithm stuff to just be like done on that, and it's like yeah, I'm very happy to have more people just like doing things and just providing ends and tools and things. Honestly, at this point, like I'm gonna have to spend a month probably just going through all the algorithm things, but I kind of would just like to spend a month instead just building crazy sims. And yeah, but I think it makes more sense to do like split between algorithms and business side stuff. Yeah, the priorities here is Puffer's got to be the technically the best. That includes the algorithms, but then also it is very important to keep everything growing at a reasonable pace, just because it opens so many more opportunities for us to do stuff. All right. Yeah, sure. Send us because I gotta honestly apologize to those guys. Like I really wanted to do way more with their lab, and then like I don't even think the pneumonia is an excuse. Like because I could have just started on it afterwards. I don't know. My whole like mental like my whole like the whole way I like framed and like looked at the work I was doing kind of just shifted a bit. I guess I don't know. I don't know. I kind of just like after that, instead of like doing a bunch of collabs and stuff, it was just like, nah, I'm gonna just like focus up and like freaking shove RL as much as I can solo with like the smallest amount of code plus so a few awesome open source contributors. Okay, cool. So plan for today is we'll have tutorials done. So if you want to look at these things, you will have like a very nice like one-page doc plus two super short M's, probably like 500 lines of code total that you can read. One basic single agent env, one basic multi-agent env. There will be a demo for the single agent one with the native API or with the Python version as well. So like, we could probably train your Python env at 100 or 200,000 steps per second without even going to C. And then there's the C to get to like 2 million. All right, cool. Back to back. See. Yep, sounds good. You're getting good results. All right. Oh yeah, I forgot that I wrote the terminal renderer for pi squared. Funny. Yeah. So when you do eval, we forcibly set your Vec backend to serial because render gets called on the first env. So you're not rendering? Is it with serial backend? So the only thing I can think of is the first env in serial is it gets treated as a driver env. Hmm? Only thing I can think of is that I've never seen it. The only thing I can think of is when we call render, we mess specifically with the first env. That's about it, though. Yeah. That's weird. Oh, I will be back after set. Info should be a list of. I actually don't even know why we have it as a list of dictionaries. All right. This is the pure Python env commented up. Refactoring squared a little bit here. Yeah, this code's gonna get a lot easier. I think I'm definitely gonna have these tutorials done today. Unless I like run out of steam. That should be at least done. I'm gonna actually just copy this thing. Perf score, return end, yeah, all good. Some of these comments are just gonna be the same. Actually retheme this as well while we're here. Buffer colors. We have a, and we just don't have a compute observation phone. That's fine. Is just a required function. This is your third first time on stream. Third first time. That's a new one. You're funny, man. Are you here for any of the technical content and just like trolling too, or are you just here to troll? I gotta know. Anything else that I forgot to comment in? Alright, so this is pretty solid. PC specs? I mean, this one's got a 4090 and a 9950X and 128 gigs DDR5. The one in the back that's on the shelf way back there has got a 5090 and the same otherwise. And then we've got like 8 more that are 4090s with Intel chips that I don't recommend. And let's see, we're getting 2 tiny boxes in like a week or two that are 6 4090s a piece. And then hopefully we'll be getting more after that. We got a lot of PCs. Now, can you send me a PC? No. PCs are for reinforcement learning. You can get PC access if you do reinforcement learning. All right, cool. This seems decent. Yeah, do reinforcement learning. I don't know what you mean. You gotta do the RL. You got 55090s? No, I only have one 5090 at the moment, unfortunately. I would like many more 5090s, but unfortunately, tariffs. I want to buy like another 30 of them, 30 or 40. I think the play might just be to wait for a little bit more revenue and then just buy them anyways. We'll see. Tiny boxes are not here yet. Actually, that is a good point. Let me go check on where are my tiny boxes. Sure. Where the heck is did I put these on my can't find the email. Oh yeah, there it is. So this was on view your order. You've received your order. They actually should be here. What programming languages do you know? All of them. But I can kind of write code in any, like, if you give me, like, a day, I can write code in just about anything. I mostly write C and Python. So you do see my comments. I don't know why you do that for free, man. You can make good money doing that. Alright, this seems like it's good. We just gotta make sure I didn't break a ton of things. This actually cleanly exits. Target has mem leaks. Tiny box, single board. Now it's it is George Hotz's like 6 GPU box. Here, let me finish this and then I'll go finish my set. Figure out what else from there. Thought that it's just like unload texture. Unload texture, close window. Oh, did I forget to close the window? I did forget to close the window. Perfect, no mem leaks. What happened here? Env creator must be a list of callables. Oh, I know what it is, actually. So we have from buffer pi squared. Why is it on psi squared? Oh, I know. Oops. Oh, that's what I set up. Still a little bit more work, it seems, to be done to get these things to, like, train correctly. Alright, I'm gonna go get my set done, and then and kill this bug, and then we will be back. I will finish cleaning up all these M's, and then we will make the ducks. Decent enough leg training for today. See, Linky, these are the type of improvements we need. Alright, I'll think of puffing alternatives. Why does this thing not train? How's there no puffer squared? Callables. Python version. And then this solves. Takes it 40 million steps. Hang on. This is 8192 total. Oh wait, no, this is because that's eval. So it'll do 20 mil. And solved in 20 mil pretty well, yeah. It's solved in 20 mil. And then just runs extra evals. Yeah, and this is fine that we have it this way because this is like our standard configuration. So this should really be 8192. Split on the same two workers would be okay, so this is 400 something K. Oh, and this does train. Cool. This totally trains. It's the same. So we can actually just start we can start putting these into tutorials and docs, right? 2 p.m. I've got plenty of time. Let's commit all this stuff up. We should probably there's one other thing we should do first. Do like a speed test thing. Oh yeah, this is not vectorized, huh? All right, this is pretty good. So this is a 270K. Do like this. We'll put this test on squared.h dot pi. Oh, that does make it substantially faster. Cool. So we gotta at least be fair to our Python, right? We can't make the Python, like, even worse than it already is. That would just be needlessly silly. What else? Cache. This should give us some crazy number. Okay, so I think that 113 million steps per second is pretty good. I don't know about you. I think this is pretty good. That put this in target. M's. Agents, number 4. Python perf test. Deck reset. Boom. Could not broadcast. 16,000. Two mains, buddy. What's this? I think we just like breakpoint. That's pretty good. Low, high, and then size. Not broadcast. Output shape. Alright, this is cool. So we do full action nvec size cache. Alright, so this one gives you 35 million SPS, which is still decent. A decent 35 million. You know? And then you have your pain points listed here. I'm going to just put these into. We'll put these into here for now, so I can commit this cleanly. There we go. What did I change there? That's fine. And this is where I wanted to cache some credentials, and we can push this. Command. Okay. Now we have all our nice new tutorial ends. And we should be able to just open up the hang on. You'll be able to just open Puffer Tank, Puffer AI, docs, ML file. And look at that, actually it has that's me right there doing, like, I have the stream on here, the new site, and then what we get to do is we get to add this to our docs page. I'm going to put this here. We are pretty well set up with the code, so I'm going to do a couple quick sets so I get some sort of exercise in today. And then I will be back in a couple minutes. And we will write the documentation section for these M's. You'll have feedback on what you'd like to see, or making it easier for other folks to write cool ultra high perf sims for RL. You let me know. I'll be back. All right. I do not like writing docs, and I especially don't like writing docs for the sake of writing docs. So I'm just going to try to look at this and figure out what is the shortest, simplest thing we can give people so that they will be able to write ends. The main thing I want to decide on is whether I want to actually put the code here or just link to it. Honestly, the stuff I have here is pretty well thought out. Um, Okay. I don't think what I even put in here. I'm just trying to think how much of the code I want to inline. I'm trying to think, like, what is the amount of stuff I need to write here to make this clear without just writing a whole bunch of, like, stuff people don't need to read. It might be better to just inline the code, no? I think it would make sense too. I mean, to kind of know all the things that I want. I just noticed I don't know how I want to structure this is all. I also don't want to agonize over it for too long. It's like pretty basic ultimately, right? Like I have good commented code for how to do this. It's a good idea to just paste the damn here. Kinda fine too. It's a lot of code to put like on a doc page though. I want to just put no code here and link to it, but like something's telling me that's a dumb idea. If I just say I'm going to paste the code and do it, like, then it's a lot easier, right? Like, okay. It's down here. I don't think that was it, you know? Yeah, let's paste. Let's see what this looks like if I just like start pasting this in. Got a whole bunch of these nice bluebirds outside. Very peaceful. I think I will go for a good walk after finishing all these docks. Just makes up random stuff. The model does. I think what I'll do is I'll put this one online, and then I'll leave the other one on GitHub. I believe it was 400K, right? Yeah. Something like that. Add this here. And bugs, man. Wham! Oops. Here. code macro thing. Free. Okay, so let's see what this looks like so far. If I open this thing, up. So that okay, that italics doesn't help. See how much code this is. Hey Spencer, I'm trying to figure out what the doc should look like here. Oh, this was totally fine. Hang on. There we go. I think that's decent. And I think what I'll do is I'll put this as like the first env. I'll give some additional tips with like debugging, and I will link the other target env, and then that will be good. That sounds good. That's what we will do. This is cool. See, the memory obsession, though, is a bit weirder than the perf obsession. It's also true. Okay, let's see what the docs look like. All right, let's see how this does. Okay. So we now have a tutorial. Writing custom environments that run 1 mil plus steps per second. We have the square down, which is a page and a half of code. And then we have a little explanation. It's fair, well commented. Then we have the C version. I messed up a parenthesis, was a paragraph or whatever. Not bad. Probably clean up links and things, but probably put some like bunch of things, but this is, I mean, this is like a nicely commented full code example. That's decent progress. Decent progress. Got the M's done. They're clean. There might still be a better way I can present it on the site. I think it'll be easier once I have like the inlineable demos or whatever. I could also put a GIF, but probably just inline a demo. Yeah. Let me see, I should probably just add some debug tips, actually. Let's do that. Okay, I know what we're gonna do. We're gonna add a checklist. don't think it does reset, does it? I honestly forget. I don't think it does. That's pretty good. Alright. That ought to be useful, right? this. Very nice. All right, I'm happy with that. Cool. It is 4 p.m. Happy Thursday as well. Use the restroom real quick, and then I think we should probably like go check on and set up some sweeps instead of just working on docs all day. Because we gotta check on our experiments and make sure we're making progress towards the final experiments on here. So no more freaking boring docs for today. I got the portion of that I wanted done, which is we have a decent environment tutorial, which is mostly just a bunch of nicely commented code. But also, you know, some additional things on debugging and whatnot. Yeah, I will be back. Here's the restroom. Get a couple sets in real quick, and then we will, yeah, we'll actually get some experiments going. We'll see how that goes. Yeah. All right. Experiments going, unless there's anything. All right, nothing to deal with there. One message. So, I haven't run any experiments in a couple of days, actually. But we had mazes working very nicely. Trying to think what type of stuff. I think we just want to get meta going. Let me see if I can get the meta end to train. Oh yeah, they changed a whole bunch of stuff, didn't they? Forgot about that. I really want to get a sweep for these guys. I'm trying to think the easiest way I can do that is. Um, think this. And get this to train. So what's their setup? Setup have? They just do a pi bind extension. No other depths? No, they have requirements. Upper. They have requirements. Pinned. Oh, they've got way too much stuff pinned. Yeah, you don't need all that, guys. Let me just see if there's anything that's like bad. Think so. Well, we'll try this and see if it messes anything up. Is that it? Oh yeah, it built something. This is like this cool like factory grid-based env type thing. here. Omega conf. A pip. Is it Hydra core? Just add this N. Duck DB. You gotta be kidding me. Duck DB? The hell is that? Okay. So apparently, is there any interp on this? I don't know what this is. Full key. Map builder. That room, okay. You just ask him. They have like a new basic config maybe for me. So is it benchmark YAML? The most you're gonna get is the incline bench sets at the moment. Move some deprecated features. Okay. So like, is this it though? I don't think it's this one. Benchmark sample. With sampling removed. All right. We need 16 agents in here. map 24. Why does not match number of agents in map? Oh, I guess it's because this needs to be 4. No, is that actually a thing? Yeah, this really annoys me. I mean, technically, I could just change. Okay, let's say that I use their original config, right? Does it load? Okay, it does. I just need to change the batch sizes then. Oh, what did this? So I have 128 times in 4096 total agents. Or is it divisible? Nope. So I just have to get. That's actually really annoying. I can multiply by 128. Maybe? That's not terrible. So we do like 3072 M's. And we have a batch size of 128 M's. Yeah, this works. Would you mind running that trade eval? Yeah, sure thing. Where do I get it? DM you? Alright, let me know. Okay, that trains. Boom. Doesn't give us any stats. At least not so far. Go get this repo. Oh, there it is. Okay, it gives us stats. Let me put this on Neptune so I can do this in the background while I do the other eval thing. Get my API token. Okay, very, very secret repo. Tops. Takes forever to build. Oh, you know why? God damn it. Forget the magic argument that makes it fast and also not break. Love when they're magic arguments that you need to make things not break. Oh, I didn't train this for enough steps at all, did I? Okay. That after I fix this thing for you. I don't know why your eval thing doesn't work. You see your errors and stuff at some point. Token. That terminal is on. I mean, it doesn't matter. It's like semi-private-ish, right? I'm just checking if the curve goes up on an environment real quick, and then we'll go back to the other environment to check if the curve goes up. Pretty much it. Is it score? Score is the same metric, right? What are we supposed to get out of this? Oh, is it? Are the params like fiddly? Oh, is it supposed to be perf is 6 to 70 or what? This score is 60? Like what? Like perf? This is, you know, 460K? Okay. That's going up. 0.6 million steps per second. I'm gonna do a set while I wait for this shit. There you go. Even better. Will do. Who gets 80 on this? More than 80. I don't know, maybe I just magically improved things. Power of Puffer. 5-minute training for 500 million steps. Is the thing supposed to render with the numbers all over the entire screen? Or did you not commit a font file? Can you check if you committed your font file? Don't file. What? Confused. Yeah, just add the font file or whatever. Go add that so I can pull this. I'll give you your eval. When you do that, I'll do back to the meta experiment. This is like what we're supposed to get, right? One of these-ish. See how this goes if I run it for 100 mil. Not at, oh, Twitter 8 message, gotcha. Well, when you get me that file, I will fix this. Alright, so let's just go get the meta box, puff box. For container. Right. We have to do oh, they have a different one. Hang on, they have a different config they want me to use. Seeing what I can get to work on this. What the heck did I just do? Um, the heck is wrong with this? Oh, we have the wrong puffer installed. Find what the base image is. Find this. 23 gigs. What's wrong with this? This is running soon. Holy. Thunderstorm out. Oh. It has started completely thundering. Hopefully we don't get knocked out on the internet. Wait, you need to run register. Wait, where is this thing? Oh, jeez. All this stuff? Then this calls this logger, which is like, blech. Yeah, that's annoying as hell. Can I just, like, do this? Can I just do this? Okay, so possibly we can make this faster if we update to our latest param sets. I believe this is... Oh, it's really thundering outside. Well, if I go offline, you know why. It is really thundering. Okay, we want 64 of these M's, I believe. And 32 of them per batch. And then we will keep this 32K. Yeah, and we will see how this goes. Okay, so this is actually slower, but we will see if it's slower on the other GPU. Okay, let's go grab here. Get full. Why not on? That's this box here. Pull. Metagrid requires. Well, we don't like that. Huh. So it's literally ignoring the recs in here. Weird. Just grab the newest one. Or fork. Ah, this is actually pinned. I don't know how it is that I've been able to run it. Does the speed environment? Your policies don't take 99.99% as the thing. Like, in the majority of RL research, your environment takes 90% of the time. The fact that our policies are taking most of the time now is just because we've optimized our environment so well. So like that wasn't a thing before us. Like pretty much everyone else in the whole rest of RL is spending like a good chunk of their compute, if not the majority of it, on the env. Okay, so this is 370. Grab a new one of these. Make sure we really give these guys some good policies and a good sweep setup. Okay, so that doesn't make a huge difference. Of course, so this. Wait, did I do that right? 416. I did that totally wrong. It's supposed to be 256 times. No, 512. Yeah. 12. 128. And we'll see if this is suddenly fast. Yeah, but not everything is VLMs. Like, we are solving problems for people with like single digit million parameters. Oh, there we go, 800K. Make sure that this is logging for us. Okay, there we go. So I will let this run, and we will see how this does. Use a restroom and get a good set in, and then we'll get this sweep set up. We'll do a few other things. Be good. Cold outside. Storming. Hey, Plasma. What's up, man? Being confused at what policy is doing? Policying. Font pushed up. Let me get that, Spence. Do you have the rewards negative? It's never that. I've never once had the sign wrong, but it's funny. Okay. Make sure I'm on the right machine. I am on the right machine. Break system packages. System. I gotta figure out a way to make it just the default be that, because it's ridiculous. Packaging woes. It's alright. Alright, puffer eval. Env. Range him. Load model mouth. Oops. Did I forget to pull? Yes. That's how it's supposed to look. Font's a little, like, all over the place, but I will give you that file. Is it resizable? Alright, I will send you this. I mean, I can keep running these here if you want. I can also help you fix your render setup. Alright, take a quick look. I will make sure this thing is good in the meantime. Not this stuff again, bound at 05. Yup. Okay. This is a run. Not amazing. We will run a sweep though. Oh. 2e7. Like 1e8. 8. 5e8. Auto. And we will see how this does. Horizon, mini batch. And we'll see how everything else does. And I'm still on the wrong. I'm on the wrong pin. Lovely. Alright, so for real this time. Okay, we'll comment all this. Oh. And Okay, we will see if this discovers anything interesting. And we'll keep checking back in on this every so often. Goes over here for now. What do you want me to do with the render, Spencer? Want me to render more stuff? What do you want? I guess in the meantime, while I'm look at our container. Reading code. I could push the Docker for now, right? Make sure I don't screw anything up this time. Fine. takes forever even with UV. Docker build. I just want to upload it so that I can see how large the compressed file is. Press size of 9.8 gigs. Well, we'll see what the new one is. Eleven downloads. For some reason, the depths file has 2K downloads. Somebody must have it in their CI. Alright, so Docker push. What's the push? How's push work? Username, tag. Username, name, tag. Does this not just work? Oh. Push. And then there is some shenanigans. I don't remember having a frickin' 2FA for Docker, of all bloody things. Yeah, I don't have one, my guy. Oh, dummy, it's right. Dummy. Did it in the wrong browser. Lovely. There we go. So we will see how large the Docker is. Seems large. If it's like 20 gigs, then I'm gonna have to figure what the heck is wrong with it, because it should not be. Hmm. This might be Restream, actually. This might be Restream, actually, folks. Re-record. Re-record. Oh. Okay. Note to self, don't push Docker images on stream again. I'll be back after dinner. This is bullshit.